Hi guys, this is your preview of what we're going to be covering in science class today. So make sure that you're watching this as many times as you need to understand the concepts before we get into our discussions in actual class today. So our concept today is Earth's interior. The standard that goes along with this is Physical Earth, ESS 81. The composition and properties of Earth's interior are identified by the behavior of seismic waves. So there's a lot of vocabulary words in there that we're going to go over to help prepare you for class. Our learning target. I can compare and contrast the speed and movement of different seismic waves. So we're going to learn more about what seismic waves are, and we're going to see how they're the same and how they are different. Remember, compare means to tell how things are the same. Contrast means to tell how things are different. So our first vocabulary word is crust. The crust is the first layer of the Earth. It's approximately 10 miles of rock and loose materials. So this part right here is our crust. Thin layer right there. Displacement means moving someone or something from one position to another. So even though you might move it like crazy like this line, the displacement is from the first point to the last point. Displacement means to move from one point to another. The inner core is the smallest layer of Earth. It's the hottest layer, and it is 760 miles thick. So that's the middle of the Earth. The mantle is between the core and the crust and consists of thick, solid, rocky substances. So from the 10 miles at the surface, the crust, and the hottest part is the mantle. The outer core is a liquid layer. It surrounds that inner core, that hottest part, and it creates Earth's magnetic field. Seismic waves are elastic waves. They're made by an earthquake or an explosion, and they go along the Earth's surface, and they may go through the Earth's interior. So these are the waves that happen during an earthquake or an explosion. That trembling that you feel, those are the waves going through the Earth's surface or through the interior. S waves are actually called shear waves, and they shake the ground back and forth perpendicular in the direction of that the wave is moving. So they go up like this. Waves are primary waves, so they shake the ground back and forth in the same direction and the opposite direction of as the direction the wave is moving. Okay, we're going to be comparing and contrasting those seismic waves, those waves that cause the shaking in the earth. I have a short video for you to watch, but while you're watching it, I want you to think how the S waves are different than the P waves and how they're similar, how they're alike and how they're different.
Earthquakes generate two main types of seismic or shock waves, body waves and surface waves. Body waves travel through the interior of the Earth. The fastest of these are primary or P waves. These compressional waves move faster in dense rock and slower in fluids. Thus, their speed and direction change. Because they are deflected by the Earth's core, P waves are not seen in the so-called shadow zone. The slowest body waves are secondary, or S waves. S waves are elastic shear waves that move material sideways at right angles to their direction of travel. Because secondary waves travel only through solids, they do not penetrate the Earth's outer molten core. For this reason, there is also an S-wave shadow zone. The slower seismic surface waves do not penetrate the Earth's interior, but follow the surface. One type of surface wave, the love wave, travels in a circular motion and causes damage by displacing materials horizontally. Love waves can be very damaging. This cracked pavement and these twisted railroad tracks clearly demonstrate their destructive power. Earthquake damage also results from Rayleigh waves, surface waves which deform materials vertically.
Okay, I hope you were paying attention to that short little video. We are going to use a Venn diagram to help us compare and contrast S waves and P waves. So with this Venn diagram, you will remember from language arts that in the middle here is where we tell how the two concepts are the same, and over here is where we tell how they are different. So we're going to go ahead and get started so you can have one in each of the parts of the Venn diagram. And then we're going to go over some more comparisons and contrasting traits of these two waves during class. So one thing that I gleaned from the video that we just watched, that S waves and P waves are both seismic waves. They are both types of seismic waves. I found out that S waves are slow and P waves are fast. These are just 3 things that I took from the video. I'm sure that you took a lot more. So if you want to go back and watch the video, you can go ahead and do that so you're ready for class. And be ready to discuss more ways that the S waves and P waves are the same and how they're different. Make sure that you watch this video as many times as you need to prepare for class. If you have any questions, email me, and have a great day.